Okay, so like I said, we're continuing from last notes, which was 2.1. That's why I put 2.1.2. Basic assumptions. Let's just review. You don't have to write this down. Okay, you have this already. You guys remember commutative property of addition and multiplication?
Yeah.
Okay, C for what? Who remembers? C for change. C for that's when you change the order. You guys remember that? Okay, the second one we learned, associative property of addition and multiplication. You guys remember? Okay, associative property. Do we change the order at all? No, we just associate differently, right? We put the grouping symbol different places. And then, do you guys remember the reflexive property? Again, it's not reflective. Okay, don't think it's reflexive property of equality when same number is equal to another number, or same variable is equal to the same variable. The second one we learned, symmetric property of equality. You guys remember that one? Okay, so it's like symmetrical. Remember I told you like if you were to put like a mirror, like this, on the left side is symmetrical, like mirror image, right? And then we learned transitive, like train, remember? Okay, so if A is equal to B, this is your anchor right here, right? And then B equals to C, of course, A is equal to C. Does that make sense? Transitive, you all remember that? And what was the last property? So I want to kind of continue on with the last property we learned. Last property we learned was, who remembers? 1, 2, 3, 4, 5, 6 people. How about 7 people? 8, 9, good. A lot more now, okay. Owen, what do you think? Closure property. There were 2 of them. Which one was the first one? Claire? Closure property of? Addition. What's the other one? Who remember? Jason, what's the other one? Yes, we had closure property of addition and closure property of multiplication. You guys remember that? Yes. What did it say? That's the most important thing. What does it? Livy, what does it say? A plus B will equal a unique real number. Yeah, if you add 2 real numbers, A plus B, it's going to be a unique, which means there's exactly one answer, right? 1 plus 4 is always 5, right? It's not 6, right? 1 plus 4 is always 5. You get a unique, right? That means you get one and only one. Unique real number. It's going to be a real number. It's not going to be a pizza or something, you know what I mean? It's not going to be a car. If you add 2 real numbers, you're going to get a real number. You guys remember this? Yes? Oh, and then don't forget the substitution property, which we learned in the very first week of the class. Very good. So we had 2 of them. Addition, closure property, addition, closure property of addition, closure property of multiplication. And of course, don't forget the substitution. This one comes up a lot. Have you noticed on your homework from last time? Yeah. We use this a lot, don't we? Okay, so that covers a lot. Okay. All right. So you didn't have to write any of these. This is just a review, right? I'm just reviewing. Is that okay? I'll tell you what to write in a minute. Are we good with any question with these things here? You guys all remember these things? Very good. All right. Okay, let's move on then. So you guys remember that little bag, right? I used. So instead of bag, really mathematically, you should really use the set notation, right? That's it. Right. In set notation, you have real numbers. So instead of writing it this way, we just write what? Instead of drawing the graph, we use the set notation, and you just write real numbers. Okay, they mean the same thing. Okay, I just kind of drew with the picture, but really mathematically, this is how you represent set of all real numbers. Does that make sense? Question?
What if we already read this yesterday? We have to write it again.
Who can answer that question? Yes, sir?
No.
No, thank you. I told you in the very beginning. Yeah. I said you don't have to write these because it's review. Okay, so guys, remember that bag? I said it's closed. It's called closure property because bag is closed, right? I don't have to add anything more inside, right, in order to get my answer inside. In other words, if I were to pick any 2 numbers from real numbers, when you add them, you can find that answer inside the bag. If I multiply into real numbers, you're gonna find real numbers inside that bag, right? So here's a question. I sort of went over this last time. Do we have closure property of subtraction then? How come we only have closure property of addition and multiplication? In other words, if you were to subtract any 2 real numbers, would the answer be unique real number? The answer is, we sort of talked about this. The answer is, what do you guys think? No? Okay, go ahead. I'm going to give you time to think about this as a group. Go ahead. What do you guys think? Do you think we could have closure property of subtraction? Okay, think about it. Go ahead. I'll give you time. Think about it. I thought we talked about this, but I'm glad that we're going over this. So what do you guys think? If you were to pick any two numbers, like 3 and 5, subtract them, what do you guys get? -2. When you do 3 minus 5, when you subtract these two numbers, do you always get -2? Yeah, so it's unique, right? You don't get like 0 sometimes or 7 sometimes, you know, it's always -2. And is that -2 a real number? In other words, is it in that set? Yes, it is. So how many people think that we could have closure property for subtraction? Raise your hand. How many people say no, you cannot? Okay, why do you say that? Because if you cannot, can you give me an example where you can't? Yes, sir. 5 minus 3 is 2. Yeah, so that's a unique real number. Well, I'm not talking about the community property. I think you guys are being confused with the community property. I'm not saying the answer is going to be same when you reverse the subtraction. That's the community property. I'm saying, will the set be closed? In other words, can I close that bag? Right? Yes. Right? If I choose any two numbers and subtract them, right? Wouldn't the answer be always unique, meaning it doesn't change, right? And is one and only one, I mean. And wouldn't the answer be real number? Wouldn't the set be closed? Guess what? We actually have closure property of subtraction, but we don't call it a closure property of subtraction. Does anybody know what we call this? Yeah. Exactly. We actually call it a closure property of addition. Do you know why? Because when you're subtracting two numbers, what are you really doing? Adding the opposite, right? So really, when you say, so that's why we don't include this one, right? Because when you're subtracting two numbers, you're adding the opposite of that number. And when you do that, isn't that the same thing as closure property of addition? Do you guys see what I'm trying to say? Right? When you're subtracting two numbers, like for example, 3 minus 5, what's that same as? It's in terms of addition. 3 plus -5. Yes, sir. Oh, sorry. Does that make sense? Do you see why we don't have we don't really say closure property of subtraction? Because this is included in where? Closure property of addition. Do you guys understand what I'm trying to say? Subtracting is same as adding the opposite, right? So it's really included in there. That's why we don't even talk about that one, right? Because it's also included in this closure property of addition. Does this make sense? You sure? Okay, let me see if you really got this. What about this question then? How about for division? Do we have closure property of division then? I want you to think about this as a group. Go ahead. Yeah, isn't division same as multiplying by the reciprocal, right? So, isn't that same as the closure property of addition, multiplication? I don't know. Go ahead. Think about this. What do you guys think? Okay, guys, a lot of you are sort of confused. What are real numbers? Can somebody tell me what real numbers are? Maybe we should be a little bit more. What are real numbers? Yes. Any numbers that are on where? On a number line. Is number like 3 over 5 on a number line? A fraction. Are all the fractions on the number line? Yes. What about all the decimals? Are they all on the number line? Yeah, even that decimal like that pi, the one that goes on forever without repeating, is that on a number line? Where is it on a number line? It's between 3 and 4. If you want to be more specific, it's between 3.1 and 3.2. It's somewhere in between, right? So real numbers are any numbers that are on a number line, right? So what do you guys think? Do you think if I were to divide any two numbers on a number line, will you be able to find that answer within the number line? No. There's one, yeah, you're correct. The answer is no. When can you not find that number? One person see it? 2, 3, 4, 5, 6, 7, not of you, 8. Who haven't I called? I haven't called, Lindsay, what do you think?
I think no, because if you divide something by 0, it's no.
That's the case. When you divide something by 0, what is that number? It's undefined. It's not. Why do we say undefined? Because it's not on a number line. Does that make sense? So therefore, the answer is no. The closure property. By the way, write this down. Right, I told you. The closure. There is no closure property of division because there is no number. It's undefined. You cannot divide something by 0. All the other cases it work, right? 2 divided by 5. Oops, I keep forgetting. 2 divided by 5, right? Would that be on a number line? 2/5. Is that on a number line, guys? Yeah, it's between 0 and 1, right? 2/5. You understand? But this number, every time you divide something by 0, what about 0 divided by 0? No. Anything you divide anything by 0, even 0 is what? Undefined. So even if it's 0 divided by 0, some people think, wait, isn't same number divided by same number always 1? Yes, except 0 divided by 0. Okay, so that's still undefined. So anytime you have 0 on the denominator, it's always undefined. Even if you're dividing something by 0. I mean, even if you're dividing 0 by 0. Does that make sense? Are you okay with that, guys? So therefore, we do not have a closure property of division. Is that okay? So now, what we're going to do with these, sort of this idea, is kind of not so fun, this game, right? Now they're going to make it a little bit more interesting. Okay, instead of having all real numbers in a bag, or I could also say, instead of all real numbers, they're going to do something interesting for you. Are you ready? Okay, let's go on to our first. Oh, before I get to first example, actually there's another simple example that I want to go over. Hold on a second. So write this down. Hold on. So they could give you a question like this on your homework, or on that worksheet that I'm about to give you. They're going to say something like this. There is only one real number that is a sum of 0.4 and 2.5. What property tells you that this is true? So everybody should know what property. So write this down. Okay, actually I'll give you time for you to write. You're all writing down already. So okay, so write this down. There is only one real number that is a sum of 0.4 and 2.5. This statement is true because of the property that we learned. Which one is it? Okay, go ahead, write it down. Right? Okay, a lot of you know. Okay, just write it down. Write it down. Put your hands down. Write it down. I'll give you time for you to write. Okay, write it down. How about someone I haven't picked today? How about I haven't picked Dana. Closure property. Would you get this right if you just write closure property? No, there were two types of closure property. Closure property of what? That's correct. It'll be the closure property of addition. Is this pretty simple? Okay, good. Now, going back to what I was saying in terms of closure property, they're going to make this game a little bit more interesting. Rather than having all real numbers in the bag, they're going to change those, what's in the bag. Okay, they're going to change that in a minute. Okay, so let me show you what I mean. Okay, here we go. Example 2. They give you a set like this. Instead of all real numbers, right? They give you these numbers. 0, 2, 4, 6. What does that ... mean, by the way? It keeps on going, you're right. Can somebody guess what number will come after 6? Yeah. 8. Chuck? 10. And then, class? 12. What kind of numbers are these? Raise your hand if you think you know what sort of number these are. They're this. Aaron? These are? Digits of 2. You mean multiples of 2? Yeah. These are positive multiples of 2, including 0, right? Does that make sense? Or you could also say, how else could you describe these? You could also say, Tawar, what do you think? Even numbers. Can I just say even numbers, or do I need to add positive even number? Positive, you're right. These are positive even numbers. Would you not agree? Yeah. Question?
But 0 isn't positive.
0 isn't positive or negative. You're right. But is 0 even? It actually turns out 0 is even. Yeah. So, yeah. Anyway. Okay, so you're right. So we gotta be a little bit careful, right? So you could say positive even numbers with 0 in them or something like that. Would that be okay? You're right. Very good. Now, here's a question. Remember, so far in our bag or in our set, we had all real numbers, right? Right? Now what do we have? We only have these positive even numbers with 0, right? And look at the operation they're telling you. Instead of some addition or subtraction, they're going to tell you multiplication. What do you think they're asking here? They're asking whether or not the set is what? Closed. Meaning, remember, the bag is the bag closed. Meaning what? Will you be able to find the answer, right, when you multiply two of these numbers within this set? In other words, you choose any two random points, right, in this set. Will you be able to find the answer within this set? If you can, guess what? The set is called closed. What if you cannot find the answer? Then the set is, actually they don't call it, anybody have any idea? Yeah. No. Good guess. You're right. It kind of sounds like it should be open, right? But that's sort of saying, we don't say the set is open, we say set is not closed. Is that okay? So it's same thing as open, but we don't use that word. Okay, so we say either set is closed or set is not
Or not.
not closed. Does that make sense? So what do you guys think? I want you to think as a group. If I were to take any two numbers within this set, right? Will the set be closed or not closed? Go ahead. Think about it. I'll give you time. As a group. I'll give you time. So you see how it's very similar to whether or not, just similar to closure property of addition, closure property of multiplication. Instead of all real numbers, we're asking ourselves, okay, if you were to take any two members of this set, right? Will the answer be unique? Meaning, will the answer be always same, one and only, right? Exactly. So, like for example, what is 2 times 4, guys? 8. When you multiply 2 times 4, is it always 8? Yeah, it's unique, right? Right. There's exactly one answer for that. It's not like 10. You know what I mean? And is it a real number when you multiply them together? And not only is it a real number, but is it in this set? Will you be able to find 8 within this set? Yeah. So, well, what about this though? What about 3 times 1? What's 3 times 1? 3. Is that in the set? So this set is not closed, right? But can I use 3 and 1? No, why not? I have to use the I have to use what's in the bag or what's in the set. Does that make sense? So in this case, what do you guys know about multiplying two numbers that are even? It's always going to be even, isn't that right? So guess what? This set is closed, as you can see. Yeah, how many people thought that the set is closed under multiplication? Very good. Can somebody think of a time where when you multiply these two numbers, you would not get what's in the set? Is there any case like that? Because if there is, the set is not closed. Yeah, what do you think, sir? Subtract. Well, see, yeah, you're right. But I'm giving you the operation. So under this operation, which is multiplication, can you think of a case where you would not be able to find the answer within this set? Yeah.
Well, I have something else.
Yeah.
What about 2 times 0?
What about 2 times 0, guys? What's 2 times 0?
0.
Is 0 in the set? Yeah, see, that's why it's closed. You're right, okay? So if you cannot find something in the set, it's not closed. But 2 times 0 is 0. So you can see. Does that make sense? Yes? Hey guys, can I do this? Can I do 2 times 2? Can I use the same number twice?
Yeah.
The answer is yes. It doesn't matter. They didn't say you can't. Okay, so what's 2 times 2, by the way? 4. Well, is 4 in the set? What about 4 times 4? Yeah. Yeah, see, you could use the same number or a different number. It doesn't matter. As long as you multiply any two numbers within this set, it is unique, meaning there's exactly one answer for that one. And what? It's in that set. Then, if you could see that, then the set is closed. That's what we say. So on your homework tonight, they're going to ask you something like this. Okay? Let's do a couple more, see if it makes sense. Are you okay in terms of why this set is closed? Do you guys understand? Okay, let's move on to the next set. So I'm going to give you a different set now. And the operation is going to be, this one is kind of interesting. Finding the average of two numbers. By the way, do you all know how to find average of two numbers?
Yeah.
How do you do that? Yeah?
You add them and divide them.
You add them and divide it by 2. And we talked about how that will give you the number right in between those two numbers, right? Okay, so look at my set. Oh, do you guys remember what we call this set of numbers? The number that starts with 1. Then you keep adding 1 to it. 1, 2, 3, 4. We actually have a name for these. Yeah, natural numbers are correct. So I could have actually written down this as a natural number, right? Without me actually listing them. Does that make sense? So on your homework tonight, they may just say natural numbers. And you should know what they mean by natural numbers. Okay, so Carolyn, what do you think? If I were to take average of any two of these numbers, do you think the set will be closed? Meaning, do you think the answer will be within this set? Well, let's do an example. Why don't you pick any two numbers? Which numbers would you like to pick? 2 and 4. Okay. Add them together and divide it by 2. What do you get? 3. Okay. Do you see 3 in here? So it looks like the set is closed, right? Because I can see. But does that guarantee you? Because we always did was we just tried one example, right? I want you to all try this now and think about whether or not the set is closed under this operation. Go ahead, everybody go ahead and think about it. I'll give you time. I want you to actually think of it as a group. Okay, you guys remember your groups? Okay, go ahead and talk to your group members. See what you guys think. Good, a lot of you actually were asking me a good question. So somebody said, okay, if you add 2 plus 4, you get 6 divided by 2, you get 3, right? That's fine. But what if you do 1 plus 2? What do you get? And then you divide it by 2, what do you get?
1.5.
Do you see 1.5 in my set or in my bag?
No.
Guess what that means, class? That's right. The set is what? Don't say open. That's not what you, okay, the set is not closed. And hold on. On your homework tonight, if the set is not closed, you should be able to give me at least one example. Okay? It could be many examples, but you just need to give me one. Okay? Because that shows me, that proves to me that you understand, and that shows me that you understand why the set is not closed. So which example could you give if you're doing your homework? Yeah.
1 plus 2.
Sure, you could do 1 plus 2 over 2, which is 1.5. Or is that the only example you could give me? No, you could give me, I have 3 plus 4 over, as long as two numbers you're adding are what? One of them is even, the other is odd, then you're going to get some decimal. Does that make sense? And as you can see, we don't have any decimal in this set. Do you see the kind of game we're playing here? Instead of talking about all real numbers, we're giving you certain number of numbers, so certain set of numbers, right? And you're figuring out whether or not the whatever you do, whatever operation you take, right, will the answer be in this set or not? Does that make sense? So this is not in the set. The set is not closed. Everybody okay with the set being not closed? And you have to do this for your homework tonight. I cannot tell you how many times people just don't write the set is not closed, but you don't show me why. Okay, that's how you show work. Does that make sense? Okay. Of course, if set is closed, you're not going to give me, the set is closed, the set is closed, because there's so many. You cannot just give me one example. It'll take you forever, right? Yeah.
So it's on the book tonight?
So let me give you an interesting one here. Take a look at this one. Look at this set. How many numbers do you see in this set, guys? 1. And what is that number? 1. Okay. So I have 1 in this set. And the operation we're talking about is multiplication. And some of you might say, wait a minute. How do you multiply one number? Don't I need 2 numbers? Something? Well, I could use the same number twice. Okay, so there's 5. So go ahead, everybody decide. Write it down. Don't say it out loud, please. Okay, just write it down on your piece of paper. Write down the example. I have this set. This set only happens to have 1 as its member. And if you were to take this operation multiplication, will this set be closed or not closed? Go ahead, write it down. Write it down. Shh, don't say anything. I want you to think on your own now. This one, for this one. Okay, on your own, what do you guys think? Go ahead. How many people need more time? Okay, let's see. Show of hands. How many people think the set is closed? Raise your hand. How many people say no, the set is not closed? Because if you could say that, then you should be able to give me an example. The set is, anybody? No one says it's not closed? The set is, of course, closed. You're exactly
I
right.
have a question.
Yeah.
Wait, when the set is closed, do you also have to give an example?
No, yeah. So in this case, you could actually give an example, but in the other case, it'll take you forever, right? Because there's so many different ways to. Okay, so especially if the set is like, if there are infinitely many numbers, right? You can't. But yeah, if the set is closed, you don't need to give me an example. But this one I just did because, what's 1 times 1, guys? 1, right? Don't you get that number 1 all the time? There's no other, right? There's no other sort of possible ways to multiply. Is this simple? So do you see why the set is closed? Right? When you multiply 1 times 1, the answer is 1, so 1 is in the set. Set is closed, right? We don't need to add anything into the set, right? All right, what about then this? Example 4b. What if I have, instead of multiplication, I have addition? And the set is exactly the same as before. So I have 1 in the set, and the operation is addition. What do you guys think? Is the set closed, or is the set not closed? Go ahead. Don't say anything. I want you to try on your own. Okay, everyone should be done by now. This is pretty straightforward. There's only 1 member in the set. Okay. All right. How many people say the set is closed? Okay. Some of you. So, those of you who said it was closed, why did you say it was closed? Anybody want to explain? Yeah.
What is 1 plus 1? 2.
Do you want to change your mind here?
Yeah.
Okay, let me see. Show of hands. By the way, guys, let me just remind you. 1 plus 1 is 2. It's not 1. Okay, that's what you multiply. Okay. All right. So, how many people say it's close? Raise your hand.
No.
How many people say it's closed? How many people say it's not closed? You guys are correct. It's not closed because when you add 1 plus 1, you get 2. Do you see 2 in the set? No, 2 is not in the set. Of course, it's not closed. Okay. And next, guess what? I'm going to do the same exact thing. I want you to try this on your own. And remember, you may use the same number more than once. Okay, so what about for subtraction and division? Go ahead, everybody try for subtraction and division. Decide whether or not the set is closed or not closed. Okay. Go ahead, I'll give you time. All right, so a lot of you are done already. I think all of you are. So for subtraction, right, by showing of hand, how many people think subtraction is closed? Raise your hand. None of you. Are you sure? Okay, how many people say it's not closed? You guys are correct. Why not? Somebody give me an example, because if it's not closed, you have to be able to give an example. How about Sierra? Not Sierra, Samara. 1 minus 1 is 0. Do you see 0 in the set? No. So did you all come up with that example? Okay. So set is not closed. Okay. Did I put an example here? Yeah, I did. 1 minus 1 is 0. Right? That 0 is not in the set. Therefore, the set is not closed. Okay, what about the last one, 4D? For division, what did you guys, who's got the, Bella, what'd you get? How many people say close? Raise your hand. Okay, a lot of you agree with Bella. Anybody say not close? No one? You sure? You guys are correct. So it's close, because what's 1 divided by 1? 1. And is 1 in the set? Yeah, that's easy. So the reason why I show you this example is because on your homework tonight, on that worksheet, some worksheets, they give you the specific operations to do in the set, right? Some they don't. All they say is this. Write this down. All they say, this is the instruction you will see, and some of you say, what are they talking about? Okay, so they say something like this. Decide. Oh, let me move it up. Hold on. Okay, they will say something like this. Decide whether or not each set is closed under basic operations. And of course, we know what basic operations are. Addition, subtraction, multiplication, and division. And they just give you a set. Okay, like this. Okay? So what do you think this means when they give it to you this way? Some of you may say, wait a minute, how come they don't give me any operations to try? They only give me the set. It says the real numbers between 0 and 1. Okay, you're all writing down. I'll wait. Okay, I'll wait. As you write this down, think about what this is asking you to do, okay? So who thinks they know what they're talking about? What do they want you to do in this? Anyone? No one knows what we're talking about here? Yeah, what do you think, sir?
It's overall.
Yeah, what do you mean by, I think you got that. You got the right idea. What do you mean overall? Like, yeah, they want you to try, right? They want you to tell them whether or not this set is closed under what? First, addition. Secondly, subtraction, multiplication, or division. They want you to try all 4 of these operations. That's what they're talking about. Does that make sense? So for example, by the way, when they say real numbers between 0 and 1, can we include 0 and 1 as this member of the sets? Turns out no. If they say between 0 and 1, we include every numbers between 0 and 1 except 0 and 1. Unless I say all real numbers between 0 and 1, including the endpoints, then you could use 0 and 1 as this member. Does that make sense? That's why I drew this picture for you. You see the open circle? What does open circle as 0 and 1 mean? It means you could get really, really close to 0, but does it include 0? No. What about open circle at 1? What does that mean? You could get closer to 1, but does not include 1. Does that make sense? So unless they say including the endpoint, you may not use the endpoints as your set. Right? Does that make sense? So yeah, and you guys are right. We have to now try for each of these operations whether or not set will be closed under addition. Yes or no, right? Close. Whether or not the set will be closed under subtraction, right? And then so on. Does that make sense? So let's try one together, okay? Here, for addition, I want you to think about this now. Look at all, I even grabbed it for you. Real numbers between 0 and 1. If you were to pick any two of these numbers and add it together, will the set be closed or not closed? So you need to write it down. And if the set is not closed, you have to give me an example, right? So I want you to all think about this. Oh, some of you already have it? It's not that hard, is it? Okay. All right, who thinks they know? Let's do this one first. Okay, some of you are still working. I'll just give you time. Go ahead, work on it. And if you're done with addition, then the rest of you could try the rest, okay? If you're already done. But let's do addition together. Okay. All right, who thinks they know whether or not the set is closed or not closed under addition? How about Lynette? What do you think?
Not closed.
You think it's not closed. How many people agree with her? That it's not closed under addition. Okay, a lot of you. How many people think it's closed under addition? How many people are not so sure? Okay. Turns out, Claire, if you were to add any two of these numbers within this set, the numbers between 0 and 1, the set is not closed. Claire, do you see why it's not going to be closed? Okay. Who could help her out? Because if I could give you an example, you'd be convinced, wouldn't you?
Yeah.
Okay. Who could give her an example so that she would be convinced that it's not closed? Because it looks like, right, if these numbers are kind of small, when you add them together, it should be between these two numbers. Right? Who could give me an example? How about Carly? What do you think? 0.6 plus 0.6. That's 1.6. Is 1.6 in the set?
Yes.
It is? No, it's outside the 1. It's bigger than 1. Right?
Yeah.
You see, that's why the set is not closed. Can somebody give me another example? Not only 0.6 plus 0.6, what else could you? How about how about Samuel? Half plus half. What's half plus half, guys? 1. Is 1 in the set? No. Anybody else? What else? There's so many examples you should actually come up with. What else? How about Owen? I mean Spencer. What did you say? 0.9 plus 0.9. What is that? 1.8. Right? Does that make sense? So I gave a bunch. How many examples do you need? Just 1. Because it, right? As long as you can find 1, then the set is not closed. Okay? It could work every single time except just one case. Still, the set is not closed. Then does that make sense? You guys get that? Okay? Are you convinced then that this? Okay, good. Now I want you to then all try, guys. I want you to try the rest of it now. For subtraction, multiplication, and division, what do you guys think? Would the set be closed or not closed? And I don't mind you guys talking with your neighbors. That's fine. Not neighbor, your groups. Okay, go ahead and talk with your group and help each other out. I'll wait. Okay. All right. Let's go over it. For subtraction, I want show of hands. How many people think it's closed? Raise your hand for subtraction. Oh, people say it's not closed. Okay. I want 100% participation. Who didn't raise your? Okay, how many people not so sure? Okay, that's fine. Okay, but we'll go over it. Let's see. Okay, so Eunice, think about this one. For people that said not closed, who could convince Eunice that this is not closed? So, because Eunice, if you could come up with, we can come up with an example. Would you believe us that it's not closed? All right, who could give her an example showing that this is not closed? How about Michael?
I said 0.3 minus
0.3 minus 0.5. Eunice, what do we get when we do that? Negative 0.2. Is negative 0.2 in this set? No, you see, as soon as you get a negative number, guess what? It's not in the set. Now, Eunice, are you convinced that this set is not closed? Does that make sense? So this set is not closed. You're right. What's another example that you could have come up with? There are a whole bunch of them. How about Samuel in the back? 0.1 minus 0.5, you still get negative. Can you give me another example where you don't get negative, but it's still not clear? What do you think? 0.1 minus 0.1 still works, right, Eunice? When we do that, what do we get? 0, right? And is 0 in the set? No. Are we okay? Do you see how that works out? So you got to think about all. So I gave you this one where it becomes negative, but you could do the same number minus same number that is in the set, like 0.1 minus 0.1. That will work. Is that okay, guys? Yes? Okay, let's move on to then multiplication. Okay? For multiplication, by showing of hands, Eunice, what do you think? Do you think multiplication, do you think it'll be close or not close? This one's sort of tricky. Pick any two numbers in this set. Do you think that number will be close or not close? Like, give me a number from this set. Like 0.5, sure. Give me another one. 0.5, sure. What's 0.5 times 0.5? Isn't it point? What? Is it higher than 0.5? 0.5 is, right? 0.5 is half, right? What's half times half? Isn't it 1/4? So do you guys see how when you multiply numbers that are less than 1, that is greater than 0, when you multiply, what happens to that number? It gets smaller, doesn't it? Because if you do 0.5 times 0.5, that's half times half. What happens when you multiply half times half? You get 1/4, right? Isn't that smaller? Right? What about, let's pick the biggest number in this set. 0.9. Let's multiply 0.9 times 0.9. That looks like it should go outside this range, right? It should be bigger than 1. Is it bigger than 1? No, what is it? It's 0.81. It gets smaller. You see? So what do you guys think? How many people say the set is closed? How many people say the set is not closed? The set is closed, guys. This one's kind of interesting. Because, okay, of course, if the number is bigger than 1, if you multiply, it gets bigger, right? But if the numbers are smaller than 1, right, if it's between 0 and 1, when you multiply them together, the number gets smaller and smaller. Does that make sense? All right. What about for division? How many people say the set is closed? Raise your hand. How many people say it's not closed? You guys are correct. How many people aren't so sure? That's okay. It turns out it's not closed. Can somebody give us an example why it's not closed? Yeah.
0.5 divided by 0.5.
Yeah, 0.5. If you divide by the same number, 0.5 divided by 0.5, what do we get? 1, right? Or you could actually make this number as big as you want. 0.5 divided by 0.00000001. Right? That's same thing as multiplying that by the reciprocal, so you can get really big. So I gave you an example: half divided by 4. Isn't that same thing as half times 4 over 1? You see, you get 2. So you guys, do you understand that? Yes, sir. Chris? Yeah. Okay. Any question? Good. Thank you. All right. Good.